So with the power of understanding that how the mean is the balancing point of the differences in a data set, you can estimate the mean in different situations, and you can even create data sets with a specific mean. So we're going to try that second thing right now. So we're going to create a data set that has 6 numbers and a mean of 11. So that is n equals 6. That's the frequency of numbers in the data set. And the mean is 11. So when we add all these numbers together, we'll get 11. But I'm not going to use the formula right now. First, I'm going to just I'm going to use critical thinking and think about the distances from 11 and try to balance it on the left side and the right side of 11. So if 11 is going to be in the middle, I want to go some on the left and some on the right. One easy way to do that is to go 1 up and 1 down, and then 2 up and 2 down. So for example, I could put 12. Well, that's 11 plus 1, so then I could go down 1. And then the average between 10 and 12 is, of course, 11. And then I need 6 numbers, so I need to add a few more. So I can just go up again. So I can go to 13 and 9. So that's plus 2, minus 2. And then I still need 2 more, so now I can grab 14 and 8. So that's one easy example of how to find 6 numbers that has a mean of 11. That's certainly not the only way. There's an infinite number of ways, but this is one easy way. Now before we go on, let's make sure this worked. So let's check our work over here at the formula. So if I plug these numbers into the formula, I have the sum of all the x's. That's 8 plus 9 plus 10 plus 12 plus 13 plus 14. All over n, which in this case is 6. That should be my x bar, or mean of 11. So I'm getting my calculator. I have 8 plus 9 plus 10 plus 12 plus 13 plus 14 equals, I want to make sure I hit equals before I hit that division sign, because I want to divide by the entire sum of what's in that numerator there. So that division bar works as a grouping symbol, so all that entire sum divided by 6. That gives me x bar equals 11, just as I had suspected. Okay, let's take this problem one step further. What if we want to add 2 more numbers to this data set, but we still want to maintain that mean of 11? So this time our n is actually going to be 8, because we have the original 6 plus 2 more. So our n is now going to be 8, and our mean is 11 still. So I'm going to copy this from this old set. I'm just going to add 2 numbers to this. If I just add 2 numbers, I can just keep going the same way I did originally and add another 15. And in that same manner that I added 1 more, I can subtract 1 more. So that's one way to add 2 more numbers to this set. And if I add those together, in my formula of the sum of x's over n, that is that sum divided by 8. In this case, that's 7 plus 8 plus 9 plus 10 plus 12 plus 13 plus 14 plus 15. Again, hit enter before you hit divides. And divide this by 8, and sure enough, we'd still have that mean of 11. So that's all well and good. That's an easy example of how to do these two problems. It certainly could get more interesting. For example, maybe you already know that the first 5 numbers of the set are actually 2, 3, 4, 5, and 6. All 5 of those numbers are below 11. So I know that that sixth number better be above 11 and still balance out those differences. So thinking these are all numbers that are below 11, and how far below? Let's see. We have 11 minus 6, or 6 minus 11. I get negative 5, negative 6, 4 minus 11, negative 7, 3 minus 11, negative 8, 2 minus 11, I get negative 9. So the sum of all the differences on the left side of 11 is 9 plus 8 plus 7 plus 6 plus 5. Remember, I'm ignoring that negative sign because I'm looking at the distance. So whether it's going negative or positive doesn't matter. So on the left, I have a negative 35. Which means whatever number I have on the right should be, there's only one number left, should be positive 35 away from 11. So 11 plus 35 would give me that 6 of 46. And if I add up these numbers and divide by the n of 6, I will surely get 11. So adding 2 plus 3 plus 4 plus 5 plus 6 plus 46 gives me 66. So the sum of x over n is going to be 66 over 6, which gives me 11, just as I had expected. So another way to make a more interesting data set, or if you already have some of the numbers, how to find that missing number.